Unit 2, Day 1, Introduction to Functions. Example 1. An internet music service offers a plan whereby users pay a flat monthly fee of $5, so it's $5 every month, and then they can download songs for 10 cents each. What are the independent and the dependent variables in this scenario? Well, back in algebra, you learned that x is always the independent and y is the dependent. So our independent in this example is going to be your number of downloads. And my dependent y is going to be the amount charged. Kind of like your total. So fill in the table below for a variety of independent variables. So they're saying you download nothing that month, well, you're still going to get charged the $5. If you download 5 songs, it would be 5 times your 10 cents, which is 50 cents, plus the $5 monthly fee, it's going to be $5.50. Same as 5.5. Okay, so if there's 10 downloads, it's 10 cents times 10 songs, which is going to be $1, plus your $5 monthly fee, it's going to be at $6. Now, you can see that as we're increasing by 5s each time, this is going up by 50 cents. Okay, so 15 was skipped over, so you skip 6.5, and then 20 is going to be at 7. Or if you wanted to do a check there, it would be 20 times 10 cents, which is going to be $2, plus the $5 monthly fee is going to be a total of 7. Let the number of downloads be represented by the variable x and the amount charged by the variable as y. Write an equation that models this function, models y as a function of x. So y is your total amount charged. So that's your total bill for that month is going to be 10 cents times your number of downloads plus your $5 monthly fees. So it's going to be y equals 0.10x plus 5. Again, x is representing your number of downloads. Okay. Based on the equation you found in Part C, produce a graph of this function for all values of x from the interval of 0 to 40. So that's my domain. So they want all the values of x from 0 to 40, and we're probably going to go by 5. So we're going to go 0, 5, 10, 15, 20, 25, 30, 35, and 40. Okay, so keep these nice and organized. And we had a little bit of a pattern up top that you noticed. So when we were at 0, we were at 5. At 5, we were at 5.5. So then you're going to see this whole little pattern here. Okay. You can also plug that equation into a graph on your calculator, and then when you hit Control-T, that'll give you your table of values, so you don't have to do any thinking. But most of us can see that pattern there. So that's why it says use a calculator table to generate those. Okay, so now you have to be really careful on the bottom here. So this is going by 2s, so 2, 4, 6, 8, 10. So this is going to be 5 right there. Okay, so there's my 5 mark right there. And then half of this would be my 15. So there's my 15. There's my 25. And my 35, and then 40. Okay, and then my y-axis is going up by 0.5s. So, like, here's 1. And then obviously here's 2, 3, 4, 5, 6, 7, here's 8, 9, and again they're in increments of 0.5s. Okay, so then I'm going to plot the ones that I see. So at 0, I'm up at 5. So there's my first point. And then at 5, I'm at 5.5. Make sure you realize you're still in between though. Oops. If I hold my stylus down, it sometimes does that. Okay. And then at 10, I go up to 6. And then 6.5. And then 7. And then 7.5. Then 8. 8.5. And then at 40, I'm at 9. So there's that. Okay, example 2. It says a function is any rule that assigns exactly one output value, y value, for each input value, the x value. These rules can be expressed in different ways, the most common being equations, graphs, and table of values. We can call the input variable independent and the output variable dependent. So remember, the output is the y and the input is the x. So you put in x, you get out y. Okay, also, you know your function. So what that is saying in all those fancy words are your x's never repeat. So every single x has to be different in order for it to be a function. So one of the following graphs shows a relationship where y is a function, keyword, of x, and one does not. Draw the vertical line whose equation is x equals 3. So remember, x is a vertical line. So if I draw this in right here, here's x equals 3. And then same thing over here. Here's x equals 3. And now part A says draw the vertical line. We did that. Give out all output values for an input of 3. So what that means is, if I look at my graphs in relationship A, at 3, I can get the point. So I go over 3, and it's all the way up at 1, 2, 3, 4. So there's the point 3, 4. And then I also have the point 3, negative 4. Okay, in B, there's only the point, if you go over 3, it's down 2, so there's only the point 3, negative 2. Explain which of these relationships is a function in Y. Okay, so my relationship B is going to be the function, because there's only, at x equals 3, there's only one output. So when you put in x equals 3, it produces one output. In easier words, the x's never repeat. It produces that unique output. Okay, so now when you look at relationship A, I have 2 different coordinates that are at 3 for my x value. So that one's not going to be a function. All right, example 3. The graph of the function y equals x squared minus 4x plus 1 is shown below. State the function's y-intercept. Now remember, the y-intercept is where it crosses over the y-axis. So let me highlight that for you. So this is going to be my y-intercept. So my y-intercept is at the point 0, 1. Between which 2 consecutive integers does the larger x-intercept lie? So my x-intercepts are where it is crossing over the x-axis. So I just highlighted those in blue. So the larger one falls between this number and this number. So if I count over, that's 1, 2. It's falling between 3 and 4. So that's the answer to part B. So it's between 3 and 4. Okay, draw the horizontal line y equals negative 2. So I'm going to use my blue pen here. Here's my y equals. A y equals is a horizontal line. Using these 2 graphs, find all values of x that solve the equation below. So basically, right here, here's the quadratic, and here's my horizontal line of y equals negative 2. Basically, this is asking you, where do they intersect, or what is its intersection points? That's really what it's asking. So if I look at that graph, it's intersecting at the point 1, negative 2, and it's intersecting at 3, negative 2. Verify that these values are x. Verify that these values of x are solutions by using the store on your graphing calculator. So basically, if you store, for let's example, that coordinate 1, negative 2, you store 1 as x and negative 2 as y. And then when you plug it into this equation, it would tell you true. And then you also have to do the same thing for 3, negative 2. Store 3 as your x and negative 2 as your y. Plug it back into that equation, and it will tell you true as well. Okay. Example 4, function notation. Evaluate each of the following given the function the definitions and input values. Okay, so now algebra year, Common Core algebra, 9th grade. You also learned about function notation. So basically this is saying right here, let your x be 3. So you're going to go 5 times 3 minus 2, and you get 13. And then you're just using PEMDAS, order of operations. And then plug in 5 times negative 2 minus 2, and then we get a negative 12. Okay, how you read these are f of 3 and f of negative 2. Okay, this also produces a coordinate. Remember, this is your x and this is your y. So it does produce the coordinate negative 2, negative 12, which would be on the graph of y equals 5x minus 2. Okay, for part B, find g of 3. So you're going to go 3 squared plus 3, apply your order of operations, and I get 12. Okay, g of 0, 0 squared plus 3, I end up with 3. Part C, h of 3, 2 raised to the 3rd power is 8. And then 2 raised to the negative 2. Remember, for any negative exponent, you rewrite it as 1 over the positive exponent. So that's a quarter. Okay, your calculator can help you evaluate these as well. All right, example 5. So boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of H hours. So basically you have this boiling water, you leave it out, and it's going to cool. So it makes sense that as time goes on, the temperature is dropping. Okay? So evaluate T at 2. So when X is 2. So now remember, this is your hours. Okay, that's your X, that's your Y. That's your input and your output. So at 2, it's 104. So T of 2 is 104. All right, T at 6, so what's the temperature after 6 hours? You come over here, look at your chart, and you're going to get 68. Okay, now this one's working backwards. It's saying find your H, which is like your X, your independent. For what value of H do you have 76? Well, look in your chart. At 76, you're at 4 hours, so H is 4. Okay, pretty easy, pretty straightforward. Between what 2 consecutive hours will it equal 100? Okay, well, it's between 100 right here, so it's going to be, H has to be approximately between 2 and 3 hours. Okay, again, pretty straightforward. Moving on here, example 6. The function y equals f of x is defined by the graph shown below. Answer the following questions based on the graph. Evaluate f at negative 1. Remember, these are your x values. So it says go over to negative 1, and it wants to know where is it at negative 1. It's at 0. So at f of negative 1, it's equal to 0. F of 1. So that's saying let your x be 1. So you come over to 1 on the graph, and you're going to go, here's 1. You go all the way up, and I'm at 4. So f of 1 is 4. Okay, last one here, f of 5. So where is, when x is 5, so 1, 2, 3, 4, 5. Here's 5. I go down, and my x is at negative 4. So f of 5 is negative 4. Okay, so you just gotta have to know how to read everything and just match it up. Evaluate f of 0. So f of 0, okay, so here's 0. When x is 0, I come up and I'm at 3. What special feature on a graph does f of 0 always correspond to? That's the y-intercept. Okay, when the y-intercept, your x is always 0. What values of x solve the equation? So basically this is saying when is the y 0? Okay. When is your y going to be 0? Well, that's your x-intercepts. Okay, we really don't call them x-intercepts. We call them roots or zeros. You're going to hear us call them zeros a ton and roots. Okay, so there's 3. There's at negative 1, positive 3, and positive 7. So it's where it's crossing over the x-axis. Okay, so x is going to be equal to negative 1, 3, and 7. Okay. Between what 2 consecutive integers does the largest solution